Hi there everybody, today we are going to look at indices and specifically we're going to go through all the different kind of rules, but we're going to start with multiplying terms, arguably the most straightforward one, but essentially if you've got y to the a times y to the b, first of all your base, your y, needs to be the same, otherwise this is not going to work. Then all you're going to do is add the powers. So for example, if I said to you 4 cubed times 4 to the 4, what essentially that is 4 times 4 times 4 multiplied by 4 times 4 times 4 times 4. So what you've got there, if I count them, 1, 2, 3, 4, 5, 6, 7, which is the same as 4 to the power 7. Well, rather than going this rigmarole of writing them all out, just to show it, the easiest way of thinking about it is, well, what's 3 plus 4? And it's going to be 7, isn't it? So it's 4 to the power 7. So if I said 7 to the 5 times 7 to the 3, again, I could think about it by writing them all out, but there's no need to, because the rule is when I times two bases with powers, then I just add the powers to give me 7 to the power of 8. All right, and 2 times 2 cubed, well, whilst there's one thing missing from here is a little 1, to say there's one of them, this is going to be 1 plus 3, so it's going to give me 2 to the 4. All right, so we tend not to see that written down, so that's one to watch out for. But it would be no different no matter if I had 3 or 4 or whatever. So it's still going to be 4 plus 3 plus 3, so that's going to give me 10, so it's 5 to the power 10. And then even if it's a negative numbers, the rules still kind of apply. All right, we haven't looked at negative indices in this particular lesson, but there is another one which is about negatives. But I said if you stick to the rules, rigidly, you shouldn't have a problem. It's going to be minus 4 plus 5 plus 3, which is going to be 4. So it's going to be 3 to the power 4. I'm pretty sure that that's absolutely right. Okay, so that is multiplying terms. Well, if that's multiplying terms, dividing terms should be relatively straightforward because it's kind of the opposite. So if I'm going to add the powers for multiplying, then I am going to subtract the powers for dividing. Okay, so the rule is here, so y to the a divided by y to the b is y to the a take away b. All right, so 4 to the 8 divided by 4 to the 4 is going to be 4 to the 8 take away 4, so it's going to be 4 to the 4. If I've got 7 to the 5 divided by 7 to the 3, well, that's going to be 7 squared. And then if we've got 2 cubed divided by 2, well, I mentioned this one a minute ago, well, that has like a little 1 which is missing, so it's 2 to the cubed divided by 2 to the 1 is equal to 2 to the 3 take away 1, so it's 2 squared. A lot written there, isn't there? And then finally, no, not finally, 2 more, isn't there? Then keep your eye on, obviously, me interchanging it a little bit. So you've got 5 to the 4 times 5 to the 3, which is 5 to the 7, divided by 5 cubed, which is going to be 5 to the 4. All right, and then obviously with negatives, so here we would be careful. So 5 to the minus 4 times, 3 to the minus 4 times 3 to the 5, that's going to be 3 to the 1. And then it's going to be take away 3, so it's 3 to the minus 2 as you write it. Okay. Now, if you're looking at fractional indices, so negative indices, which is another lesson, they'll explain what that means. But obviously, for now, we can leave it written like that. Okay. Right. Powers of a power. So this is you've got something to the power and then to another power. So index to an index, essentially. So something looking like this. So if I've got 4 cubed squared, what actually that means is 4 cubed times 4 cubed, doesn't it? Essentially. So if we're going to write that out, 4 cubed times 4 cubed, that's 4 to the 6. Well, looking at these two, there's got to be a quicker way of getting 6 out of these two, and of course there is. Just times these two. All right, but essentially that's what you're doing. You're doing 4 cubed times 4 cubed, so there's two lots of it, so basically we've got 6. So 7 cubed cubed, all right, that's going to be 7 to the 9, again 3 times 3, but of course it gives you an illustration there as to why, because I've got 3 lots of 7 cubed. All right, so 9. So making it quicker now, so 2 times 4 to the 3, it's going to be 2 times 4 times 3, which is 2 to the 12. And bracket in a bracket, so let's do this one step at a time. So you've got 2 to the power 4 squared, so that's 2 to the 8. And then square it again, which would be 2 to the power 16. Okay, there you go. And then finally, but no means least, is that if you've got a negative, well, we treat it exactly the same way. So this is going to be 3 to the minus 20. All right, again, I'm not worried too much about negatives at this point because that is in another lesson. All right, fractional and negative indices. Right, so converting numbers to use index laws. So this is about manipulating numbers. All right, and more popular recently with the current GCSE. So definitely make sure you are paying attention to doing this particular one. All right, so if you're given 4 times 2 to the 4, well, what we've done so far up until this point is you've had powers with the same base. And what you'll notice is these numbers here, the 4 and the 2, are different. So this doesn't work. So I've got to manipulate the numbers so that they have the same base. So I'm thinking about the 4. I'm thinking, well, what is that as a power of 2? Well, as a power of 2, that is 2 squared. All right, it's 2 times 2. It's 2 times 2. So that is 2 squared. So if I do 2 squared times 2 to the 4, then my answer is going to be 2 to the 6. All right, 2 to the 6. And here, you've got 2 to the 5 times 8. Well, again, same problem. So I'm going to try and manipulate this one. Well, this one here is 2 cubed. So therefore, 2 to the 5 times 2 to the cube equals 2 to the 8. And then over here, right, I've got 27 and 3. Well, I know that 27 is 3 cubed, 3 times 3 times 3. So that's going to give me 3 to the 6. So you're probably starting to see that what I am doing is I'm familiar, and this is probably where you need to get to, I am familiar with what my square numbers are, what my cube numbers are, so that I can manipulate them to kind of get me to pull things together so that I can bring them together as using laws of indices, essentially. All right. So here is another example. So this is about using algebra now and equations. All right. So what I've got is something times 2 to the x equals 2 to the 8. All right. So in terms of the indices rules, we added, didn't we? All right. So I've got to change my 8, which you now know has been 2 cubed. So you've got 2 cubed times 2 to the x equals 2 to the 8. Now the rules of indices is that I add these two to give you this. All right, so I can actually drop this bit at the bottom because actually what I'm saying is 3 plus x is equal to 8, isn't it? Not 3 plus x is equal to 8 in terms of the indices rules, so therefore x must be 5. All right, because what we're saying here is these two added together must give you that. And I can check that if you want. 2 cubed times 2 to the 5 is 2 to the 8. All right, so x is going to be 5. So this bit on this page is certainly more and more becoming popular. The idea of you being able to manipulate indices to be able to kind of do something with it where the base is slightly different. But of course, what you need to know is how do I get the bases to be the same? And as you probably would expect from a GCSE perspective, they're not going to be powers of 5, 9, 17, 24. They're going to keep it really, actually it might be 5, but they're going to keep the number very, very small. All right, because obviously they are talking about using indices and powers, so they want to pick numbers that you are more used to. So powers of 2, powers of 3, essentially. I'll keep the numbers really kind of small. But I would urge you, again, knowing how popular this is at the minute, is to get yourself onto maths-school.co.uk and do some practice. There is a link at the bottom of the page. Okay, well, thanks for listening.